Good morning. Today we are with Joaquín. He's PhD in Science Computer and Telecommunications Engineer. And in LifeWatch ERIC, he does the data management and blockchain. Good morning, Joaquín. How are you?
Good morning, Belén. Nice to be here.
Good. Well, I want to ask you, Joaquín, what is blockchain?
Okay. Blockchain is a really new technology because it was developed in year 29. It is a very curious, a very disruptive technology because it has some qualities that we cannot find in any other technology. First of all, I would like to highlight is its discovery or its development, because we really don't know who develops, what group or what person developed this technology. We only know that the pseudonym was Satoshi Nakamoto. He or she developed the technology in 29. He put all the development, all the code in the internet, and he started the most famous blockchain application, which is Bitcoin, which is worldwide known that application. In 2010, he left the project. He said that he didn't want to stay anymore there. We don't know what person or group of person developed that technology. That's the first point, because I think it's a very remarkable thing about this technology, because we really don't know who put that technology there in the internet. Second, what are the main characteristics of this technology? Because it has really some qualities that are suitable for the development and for the treatment of big volumes of data, mainly relative to biodiversity and ecosystem services. The main thing about this technology, I would highlight that everything that you write in this technology can never be modified by anyone, by any technology, by any hacker, by any whatever. We can imagine blockchain as a big notebook, an electronic notebook, where you have pages. Every page, we say that every page is a block. That is the reason of the name. Blockchain is a chain of blocks, a chain of pages in that notebook. You can write whatever you want in that notebook, following some rules. But once you have written something in the notebook, no one can modify it, no one can alter it, no one can remove it, and no one can destroy it. We say that when you write something in blockchain, it is writing in a stone. Okay, and I would like to highlight that characteristic of the technology. It has more characteristics, but the main thing is that you can never alter, modify, or destroy any information writing in a blockchain, and that is very important for biodiversity and ecosystem services. Why? Because one of the main points about the information management in systems related to biodiversity and ecosystem services is something called the FAIR principles, F-A-I-R. That means that the information must be findable, accessible, interoperability, and reusable. And if you use blockchain, automatically, in a native way, the information will be absolutely compliant with the FAIR principle. But more things. Another very important thing about the information related to biodiversity and ecosystem services is related to its traceability. Because when someone writes a paper, makes an experiment or something like that, a very important thing is the origin of the information, the treatment of the information, and how that information has arrived to that paper or to that experiment or whatever. And the traceability of the origin of the information and all the management that information has had during all its life cycle is very important. And using blockchain, you can have the full traceability of the information from the very beginning of it, because it's something native to the blockchain technology.
So that's the way that blockchain technology contributes to the study and and the conservation of biodiversity, right?
Yes, that is using. When you use a blockchain system, automatically you are complying with the FAIR principle. So that is a very important thing, because there are a lot of systems that in Europe or all over the world that make other things in order to preserve the traceability and the complying with the FAIR principles of the information. But they have to do a lot of things in order to be compliant with that. When you use blockchain to do that treatment, automatically you have to do nothing. You have to do nothing because you have all those characteristics related to traceability, related to findable, to accessibility to the information automatically, simply because you are using that technology, of course, with the application related to blockchain technology that I will speak later about the application we have developed for our blockchain system.
Okay, and you also use LifeBlock. How does it benefit the biodiversity and ecosystem services too, and how does it implement to the FAIR principles?
Okay, that is a very good question, because blockchain is the technology. Okay, and the most famous, for example, as I said before, the most famous blockchain application is Bitcoin. Bitcoin is a development, a specific blockchain development made for currency or for cryptocurrencies and things like that. Okay, using the blockchain technology, we have developed our own blockchain inside LifeWatch ERIC. Our blockchain is LifeBlock. Okay, LifeBlock is a specific blockchain especially developed for the management and treatment of information related to biodiversity and ecosystem services in this first version of LifeBlock, because in fact you can use blockchain to manage almost any kind of information. But our main objective at the beginning has been to develop applications inside LifeBlock in order to be able to manage big amounts of data related to biodiversity and ecosystem services. So that every time we receive data, and we have different ways of receiving data or harvesting data from other information services, we store that information in the LifeBlock system, taking into account, so writing the origin, the source of that information and all the characteristics related to the source in order to preserve the traceability of the information. And once it's right in there, every time that information has any kind of modification or whatever, everything is traced inside the LifeBlock system. So what we have done is develop our own blockchain system in order to be able to manage big amounts of data, in this case related to biodiversity and ecosystem services for this first version. And at the time of developing that, we are absolutely compliant with everything related to biodiversity, ecosystem services, and in order to be compliant with the FAIR principles, as I say at the beginning, and in order to preserve the traceability of any piece of information inside that system.
And how does LifeBlock assure the privacy and security of the data?
Yes, that is also a very good question. Every user or every organization, because inside LifeBlock you can have a single user or an organization, it doesn't matter. It's identified as in any blockchain system by a public key and a private key. Okay, in our system, we give the possibility to the users, if they want, to have login and password. That is an option. But if they want to remain anonymous in the system, they can do it by using a public key and a private key. And even using things like MetaMask wallet and things like that will be very well known for blockchain users. But you can use login password, or you can use private key and public key. Anyway, every time a dataset, an information dataset arrives to LifeBlock to be writing in the LifeBlock system, that information, that is metadata plus dataset, is automatically assigned to the user who generates it. the user or organization who generates it, is automatically assigned. Every piece of information inside LifeBlock is assigned automatically to a user. The user is the owner of that information, and the user has the right to give permission for that information to be public or private, or even to authorize other users to use it, or simply don't authorize any user to use it and use the information only for the user. So that guarantees the privacy and the security of the information. Well, the privacy. The security is guaranteed thanks to the use of the public and private key. The owner of that information is the owner of that private key, as it happens in all the blockchain system. Also, inside LifeBlock, like in other blockchain system, any user have the possibility of allow other user even to copy the information and to generate new data sets of information starting from the information of that user. But if a user gives permission to other user to copy that information, that copy action will be automatically traced inside the system. And if user A gives permission to user B to copy information, and user B use that information for anything, automatically, if you go to LifeBlock, you will have the information that user B has used this information that comes from user A. Okay, and even a user has the possibility not only to give permission to copy information to other user, even it has the possibility to transmit, to send information from a user to another. He will not have the information, and the information will arrive to the account of another user. You can do it in a private, anonymous way using public key and private key, like in other blockchain system, or even you can use it using login and password. That is not typical of blockchain system, but we have done it in order to be more user-friendly with some users that perhaps are not familiar with the public or private key. Every user, in fact, is using public and private key, but when you use login and password, you are not aware that you are using that, but the system automatically assigns you that combination.
Okay.
Okay.
And how does LifeBlock facilitate the interoperability between the different organizations and platforms of that data?
Okay, that is always has been a big problem mainly in European and worldwide research infrastructure, because there is a problem. The information nowadays is divided in big databases that are spread all over Europe and all over the world. What we have done with LifeBlock is the following thing. We have federate, at this moment, we have federate some research infrastructure, European research infrastructure. We have, at this moment, we have federate GBIF, Elter, Zenodo, and Disco. Also, we have federate, of course, the LifeWatch ERIC metadata catalog, and we have federate Ridian, which is a big database relating to biodiversity ecosystem services of Junta de Andalucía. We have federate that. What does that mean? That every user in LifeBlock, inside the LifeBlock system, has the possibility of look for information, of search for information, like you do every day in Google, in any of these research infrastructure. So we provide to the user information from our sensor network. We will provide in the future information from our nanosatellite, but also we give the user the possibility to search inside, at this moment, 6 research infrastructure, big research infrastructure, and the user has the possibility to search using common keywords, to have all the results in the user dashboard, and they have the possibility to import the results from the research, import all the metadata, but also the data sets inside the system. And even they are able to search inside the data set, which is a thing not available nowadays to any other research infrastructure. So that is the way used to federate those research infrastructure, that are like big databases of information related to biodiversity and ecosystem services. The user has the possibility of importing the information and then use that information to an experiment, to a paper, to whatever. Every information that any user import from other research infrastructure, it's traced inside the system. So, for example, if you import something from GBIF and you use inside LifeBlock in the registration will have a trace that it says this information comes from GBIF and from this data set of GBIF. And also, this is only the beginning, because apart from that, apart from implementing that we call the federated search, where you are able to search inside other research infrastructure, apart from LifeWatch ERIC databases, we have aggregate the possibility of doing semantic search. Semantic search is a big step in searching, because first of all, there are no research infrastructure with semantic search nowadays. We are the first one implementing it in Europe. Second one, it makes much easier to search for information than using federated search. Why? Because in federated search, when you search for a word, you're searching for a word in any field of the information. But in, for example, if you search for the word Seville, or Sevilla, in Spanish Seville, you will search for people whose surname is Seville, but you will search also for experiments or data that has been taken in any place related to Seville, and you will search for organization related to Seville, etc., etc. But when you use semantic search, you can say, okay, I want data set or data comes from a person whose surname is Seville, or comes from an organization who is in Seville, or data taking in the place of Seville, in the location of Seville. So you can differentiate your search and you can make your search more precise. Okay, all the information that we harvest, that the users import from any research infrastructure, automatically we insert it in our semantics databases in order to make search more easy and more friendly to the user. And also all the information that we are extracting for our big remote sensing network and in the future from our nanosatellites are also going to be processed by the semantic database in order to make search much easier for the user. So that is the way we are integrating research infrastructure, and we are trying to make the search of information, which is the first letter of FAIR principle, easier for all the users of our community.
Good. And could you tell me a successful example of the use of LifeBlock applied to the biodiversity?
Yes, we have, of course, we have been developing during the last 3-4 years 6 IRDF projects, whose names are Alborán, Indalo, Sunhal, Envic Chulab, Smart Food, and Smart Ecomountain, with different organizations and universities of Andalusia. And we are, as I told you before, extracting information for a big sensor network related to this project, between other things that we have done. And we are extracting this information, and also we are, of course, storing the information inside LifeBlock and storing the information in the semantic databases, and then inside the development of these IRDF projects, we have developed workflows. In fact, we are developing now, because the projects are still ongoing, 22 workflows where the user, any user, because this is open science and they are open to any user, citizen or scientific, have the possibility of using that information inside the workflows in order to extract conclusions, data, or whatever. For the people that are not very familiar with the workflows, they can see the workflows as a machine where you, an informatic machine, an algorithm, where you insert different data sets in one part. They are analyzed. For example, you can insert data related to temperature, pressure, or whatever. They are that information is correlated, even geographical information is correlated, and you can extract conclusions of that information. We have developed it using LifeBlock, using our semantic infrastructure, and using our workflow system inside these 6 projects. We have developed all that information that it's starting to be available to users. And also what we have done is that every time you execute a workflow, all the history of that workflow, what information was the source in order to execute that workflow, how the workflow was executed, what information units, we call that wrappers, what information processing units we have used, and what results have we obtained, have the user obtained, that everything related to that can be very useful for papers, for information, for research projects, etc. All that information is traced and is stored in LifeBlock. So that is, if later someone wants to know how do you extract that information, how do you get to that conclusion, how did you do that, you even don't have to ask to the author of that information. You can see all the traceability of the information, all the trace of the information, and you can see all the origin, all the processing of the information, and you can see that the FAIR principle has been done in the processing of that information. That is a big project that we have developed, a big 6 project, not only one, but we have developed common infrastructure at the time of developing that project that we have been done during the last 3 years.
And what are the principal challenges when it comes to managing this type of data?
Okay, the principal, I would say that there are 2 or 3 important challenges. First of all, we are speaking because we are speaking about disruptive technologies that we are developing nowadays. Okay, disruptive technologies is associated to technological people, to what we could call to ITC people. And these ITC people, I am in that group, we had to speak with scientific people not so familiar with that, with the use of disruptive technology. And I think that is a challenge. There is a big challenge there that we have to solve, and we are trying to solve little by little, to make the access to this information and to these tools as easy as possible. Because if we don't make that the information and the tools to be available to the scientific community and to the user, to the citizen community, if we don't do this in a very easy way, in a very user-friendly way, as we say, we are doing things for no one, only for us. Yeah. So that is one of the big challenges. I would say that there is another important challenge related to information management and related to be able to extract really useful information, because there is a lot of information nowadays, a lot coming from different sources. Only imagine the information we now in our data logger, the sensor network that we are developing. For example, we have the possibility even of inserting cameras. Cameras that are sending us information in real time all the time. Imagine the amount, the information that we are retrieving, or even extracting information from sensor, from temperature, pressure sensor, etc., etc. That is a big amount of information. I think there is a big challenge there to be able to understand that information, to give that information to the scientific community in a suitable way, in a friendly way, so that they can use that information for the workflows, for investigation, for paper. And I think that is another big challenge.
And how do you see the future of LifeBlock and blockchain for the biodiversity, for using it in that atmosphere?
Okay, the truth is that it's the first time that a blockchain technology is used. I am speaking about Europe. There are projects in United States, there are projects we know in Australia also, but it's the first time they use blockchain technology inside biodiversity and ecosystem services research infrastructure, first time in Europe. I think that, but there are a lot of organizations, a lot of research infrastructure that are asking us, are following us, and I think that we only have started the way, a long way, because we have to be able to extend this application to other fields, to make it, as I said before, easier for the scientific community, for the citizens to use them. And also in the LifeBlock system, it's a very open system, an open blockchain system, where a user will be able to develop their own application, because we have developed very concrete application for managing very concrete type of application, and I think that is a challenge. And I would look also in the future, because we have been working in the ERDF projects also in the use of artificial intelligence applied to the system, and that is a challenge, and that is part of the future, the use of artificial intelligence inside blockchain system, in order to be able to make this faster, and to make the search of information faster and easier for the users.
Thank you very much, Joaquin, for this information. It was very important, so thank you.
Thanks to you, Belén. Nice to meet you.